Hi guys, today we're going to talk about solving logarithmic equations, and in this video you're going to need to remember, or during this lesson you're going to need to remember the properties that you learned for logarithms. So we're just gonna start out and we're going to try to solve these. The ones that you're seeing on the screen, they are already solved for you, so I'm just going to go through the information. All right, so if we look at this first problem here, you have log base 4 of x squared equals 7. Now the goal is to figure out what x is. So a property that I know is to power down or bring the 2 down in front. So now we have 2 times log base 4 of x, and that equals 7. Now we don't know what log base 4 of x is, but remember, that is a value. You cannot separate it. You cannot remove the x from it. You have to determine that value. So we've got 2 times that information that contains the x equals 7. So let's get rid of the 2. So we divide this side by 2 and divide this side by 2. And we'll get log base 4 of x because the 2's cancel. Log base 4 of x equals 7 over 2. And now we can rewrite this problem in exponential form. 4 to the 7/2 power equals x. All right. You could rewrite this, or you could plug it into your calculator and figure out that it's 2 to the 7th power, which is 128. So those were the properties. We use properties here. Let's continue over here. Log, we don't see a base. It's understood to be 10, called a common log. Log of 45x minus log, still no base there, so it's a common log, of 3 equals 1. Now, since they have the same base, I can apply the property that says we're subtracting. My logs have the same base, so I can divide the numbers here. And it's 45x divided by 3, so that's where you get this setup. So log of 45x divided by 3 will simplify within, and you'll get log of 15x equals 1. Now, this is the step that most students aren't aware of, or it doesn't come naturally. Since we have log of 15x, and we're trying to get this x by itself, I don't have anything that I'm multiplying here by, so I can't divide and get rid of it. I need to get this x out of here, but it's connected right now with this log, and I can't just tear it apart. So in order to get rid of it, I need to eliminate the log. What do I do to undo a log? Well, I put the log in the exponent and use the same base. So because this is a log of 10, because it's common log, I use a base of 10, but what I do to one side, I have to do to the other. So this information that's right here, log of 15x, goes up in the exponent, and I have a 10 as the base, so that will cancel out that. And I'll have 15x equals, well, 10 to the first power is just 10. Notice everything that was here becomes exponents when you use a base of 10. So the 1 is now in the exponent. And then, of course, we divide by 15, and simplify, and you get 2/3 there. All right, in this problem, I have 2 logs on one side. We want to try to condense it down to 1 log. So they are both common logs. They both have the same base. It's understood to be 10. So that means I can multiply, because I'm adding, I can multiply x times x plus 9. All right, so we get log of x times x plus 9 equals 1. Now again, we need to figure out this part, but it's connected with a log, so we need to get rid of the log. Whatever the base is, raise this whole thing up into the exponent, and this number also gets raised to the exponent, because what I do to one side, I must do to the other. Using a base of 10, the logs will cancel, and we'll just have x times x plus 9 equals 10. So distribute that in. Now you have a quadratic, and you still have to solve for x. So going back to all of those things that we've already learned, we have to factor, or if you can't factor it, you use a quadratic formula. Okay? And then this last example says, well, we have log base 3 of x minus 5 equals 2. Now, the properties, there's nothing being added or subtracted like here where I had two different logs that I could combine together. This is already a single log. I just need to get rid of the log so that I can have x minus 5. So because the base is 3, if I raise everything here to the exponent and use a base of 3, I will be able to cancel because they share the same base. Of course, whatever you do to one side, if I raised everything up into the exponent, I have to do that over here too. So 3 squared is 9. So I have x minus 5 equals 9. Move the 5 over, x equals 14. So let's try a couple problems. Sorry, it's a little blurry. It looks a little blurry on my screen. So the word solve is just telling me what to do. Here is the problem. 3 equals, let me change my color here. 3 equals log of 8 plus 3 log of x. So I have 3 equals, well, they have the same base, but currently this 3 here, I cannot work with it being out in front. I can't do 3 times something plus something else. So I need to put this 3 back. So I'm going to use the properties and put it back here. And now I'm going to say I have log of 8 plus log of x cubed. Now that I have it written where it's log of something and log of something, then I'm adding here, so I can multiply the 8 and the x cubed together. So I'm going to have 3 equals log of 8x cubed. Now, we're trying to solve for x, but it's connected to this log, and there's nothing else I can do. So right now what I'm going to do is I'm going to raise all of this into the exponent on both sides. I have a common log here, so I have a base of 10. So I'm going to say 10 and raise all of this up into the exponent. Log 8x cubed, that's an x there, and equals 10, because I used the base over here, I have to use it over here too, to the third. So now I have 1,000 equals, well, the 10 and the log that has an understood base of 10 get canceled, and I have 8x cubed, divide by the 8, divide by 8. I don't know what that is off the top of my head. I should, but I don't. 1,000 divided by 8 is 125. So 125 equals x cubed. And of course, if we take the cubed root of that, take the cubed root of both sides, we will have x equals 5. And we could plug that back in to see if it works. And it does in fact work. All right, let's try the next one. I need to solve 2 log x minus log 4. So I'm going to go ahead and put the 2 back up here so that I can have 2 logs. So log of x squared minus log of 4. Now I didn't add anything or change that side. I just put a number that had been moved. I put it back to where it's supposed to go so I don't have to do something to both sides. Equals 0. Alright, now I am subtracting. I have the same base, and so I end up with 1 log, and I say x squared divided by 4 equals 0. Again, I did not change or add anything to that side, so I don't have to do it to the other side. I need to get rid of this log so that I can figure out what x is, because right now they are stuck together. So look at the base. Right now it's a common log, so it's understood to be 10. So I'm going to raise all of this up into the exponent. So I have 10 to the log of x squared over 4 equals, and then over here this gets raised up into the exponent, and I'm using a base of 10 again, 10 to the 0 power. Well, we know that that cancels the log here. I have x squared over 4 equals 1. 10 to the 0 power, 1. Multiply by 4, and we will have x squared equals 4. Take the square root, and we'll have x equals plus or minus 2. Now we need to check both of them and make sure, because remember with logarithms the domain was a little bit different than with exponents. So if you plug in 2 into your calculator, 2, hit the log button which is beside the 7, 2 log positive 2, close parentheses. So what I'm doing is in my calculator I'm typing this information in, and for x I'm using the positive 2 here, minus log 4, close parentheses, equals, and my answer says 0, and that is what I was supposed to get. So now I'm going to try the negative 2. 2 log, plug in, negative 2 minus log 4, make sure you close your parentheses, and I got an error message because negative 2, a log of negative 2, you can't do that. Remember the shape of the graph, it approaches the y-axis, so when you're saying, hey, use an x value that's negative, that's over here, and my function is going down like this. So negative 2 is incorrect, so just x equals 2. All right, so that's it for this video. Try the homework problems and let me know if you have any questions.